Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Welcome back to Stories from Space. I'm your host, Matt Williams, and joining me in the booth today is science journalist, columnist, and author James Maynard. James, thank you for joining us.
Thanks for having me, Matt. It's great to be here. I love your show.
Oh, thank you. Love yours. To give viewers a little rundown on what you've done here, you are the publisher of the Cosmic Companion podcast, which was named one of the top 25 science newsletters on Substack. Cosmic Companion has also been named the best astronomy podcast in the world by Starlust and Backyard Stargazers. And you've been named one of the top 15 astronomy podcasts for 2021 on Feedstop and one of the top 20 astronomy podcasts for 2021 by Whelp. James Maynard has also published the book The Light of Alexandria that explores the history of the first 1,000 years of science, and has been named a professional member of the Meta Institute for Computational Astrophysics. So, James, I have a lot of questions regarding how this all began, because needless to say, this is a pretty impressive dossier here.
Oh, thank you. Thank you.
Yeah. So, as I understand it, you're sort of NASA legacy. Your parents were both worked for NASA during the height of the space age?
Very close. My father was an independent contractor for NASA. My dad, Bob Maynard, was an electronics genius. You know, the guy could just take, two pieces from the toaster and a television antenna and build a nuclear reactor out of the thing. And so in the early 60s, when the Apollo project was coming around, he wound up getting a contract to design a whole bunch of electronics for the Apollo missions coming up. And although my dad was great with electronics, he wasn't the greatest at managing people. We all have our skills and our challenges. But he found a woman who was just coming off of the Redstone program that was ending at the time, who did manage people really well. And of course, he hired her. They fell in love. They wound up having me a couple years later. And then my dad went on later on to start designing electronics for the shuttle, among some other things that he was doing. And so I grew up around the space program. We always had the telescope. We had one of those great 8-inch Celestron telescopes, the orange tubes, and a classic telescope. And we built radio-controlled models every weekend. We'd go out and fly them. We'd, see things up in the sky, do astrophotography. And my other great influence as a kid was Carl Sagan. I just read every word I could get that Carl Sagan put out. If he wrote it, I wanted to read it. And I remember I literally wore out the bindings on 4 hardcover copies of Cosmos.
Yes.
When I was around 10, 11, it was just, that was really, those 2 peers were really my grounding for my early direction in the science.
Yeah. And in fact, I was sensing that there just from the name of your podcast, the Cosmic Companion. I felt that sounds to me like a tribute to the Cosmic Connection by Sagan. Is that any truth?
Actually, I honestly did not have the Cosmic Connection per se in my head when I came up with it. But I've always thought it was a little bit lovely to be a little alliterative. So I've always loved alliterative things, titles and names and mottos and And admittedly, one of my first thoughts was Cosmos,
Mm-hmm.
you know.
Yeah.
And so I didn't specifically want to do that, but I also loved in it how in the show Cosmos, I want to talk about this later, but Sagan would, pretend to fly around in a starship of the imagination. And he brought people to other worlds and other times. And that's a mission that I have dedicated my life to carrying on, using the best technology available to bring people to other worlds and to teach them in an enjoyable human way. And so I thought, wow, what I like about this is that he was like a companion to people. And that's what I want to be. I want to be a companion as we go around, a friend, a guide. So, I was playing with all sorts of names, universe or guide, or, whatever. And just between that and just loving the alliterative sound of Cosmic Companion, that was the overall winner.
Mm-hmm. So really just sort of a happy, well, cosmic convergence, you might say.
Exactly.
Everything just came together. I also noticed from your bio info that Asimov was one of your big influencers. You were a big fan of his. Do you have any favorites among his many books?
Oh boy, you know what I used to read all the time were not his works of fiction, but his works of nonfiction.
Oh.
He wrote, of course, something was it 400 or 500 books during his lifetime, and probably I'm gonna take a wild guess at saying roughly half of them were nonfiction. He had a book, and I think it was called The Solar System and Back or something like that I read time and again, which was just looking at what was known about different planets at that time. But what's interesting is that when I used to read so much of Asimov's works, that I found parts of his books repeating.
Mm-hmm.
Like he would lift almost entire chapters out of one book and just put it into another one.
Ah.
And I thought, and at the time I felt cheated. I was like, oh my God, what are you doing? I've read this chapter before.
Mm-hmm.
But now, as someone who is producing content, I see the advantages of repurposing content. And I'm not sure I would lift entire chapters, but
Yeah.
Asimov was absolutely a huge influence for me.
Mm-hmm. I know exactly what you mean there. It's like, why should I have to cover similar ground more than once? Why can't I just repeat what was said there? And
Right.
yes, in an age of where you can cut and paste and drag and drop, I mean, it's also very easy. But yes, self plagiarism, as I've been told, is still technically that way. But yeah, a prolific writer back in the time when you could get away with it, I could totally understand that.
Yeah, I mean, if you
Yeah,
can't steal from yourself, who can you steal from?
exactly. Right.
But what
That's a
I love to
silly
do,
one.
I'm just saying, what I love to do with my stuff is because what I do now is mostly video and podcast and metaverse stuff, three-dimensional environments,
Mhm.
um, that I can repurpose things in completely different ways. Like I may create a background for a video and then use it later in a 3D simulation in Second Life or something like that, which is
Mhm. In fact, you got quite a bit of experience with VR modeling, don't you? I mean,
yeah.
that was something that the Meta Institute for Computational Astrophysics, something they did quite a
Yeah,
bit there back in. Well, that was 2008. But I mean, VR has really progressed considerably since then, hasn't it?
It really has. It really has. And what that group did, we had some fantastic scientists and developers and such from around the world. And there's a potentially simple problem in physics. It is called the multi-body problem.
Oh, yeah.
And, all right. So if you have two objects, to just simplify this, say let's say the Earth and the Moon going around each other. Figuring out the orbital mechanics of those is pretty straightforward. It can basically be done by a freshman in college. But when you add a third body or a fourth or a fifth or 119th, the mathematics becomes really complicated really quickly. And so that's what the Meta Institute was really about, was using Second Life, using these 3D environments to model bodies of three or more systems within Second Life and let them orbit each other and see what happened and record it and try to get some insight on that long-standing problem.
Mm-hmm. So the globular clusters, trying to figure out how they work. Yeah.
Exactly. Yeah, globular clusters are a perfect example.
Yes. Well, yeah, that was the example that I read in the description for what Micah or Mika,
Yeah.
however
Micah,
you pronounce that, Micah. Yeah, for what they did, and addressing that mystery in astrophysics. So, yeah, in terms of also, you have a degree in physics and chemistry, and you've also taught. And what exactly was that like?
Oh, I've always loved teaching. I'm primarily an educator, and I've always loved bringing science down to earth and just trying to make it so that people can really understand things without having a technical or mathematical background. I've known so many brilliant instructors, brilliant physicists who had a very good idea of how the universe worked, and many did a reasonable to fantastic job at teaching, let's say, upper class.
By upper class, you mean students who had a working knowledge of physics?
Yeah, right, exactly. But when presented with an audience who may not have more than a passing interest in science, they may not be able to connect with them in some ways. And so, for instance, when I was an undergrad, the one of the most popular gen ed science courses was astronomy. And I think that speaks to how popular astronomy is in the human psyche. But the instructor who taught it was one of the most brilliant people I ever met. But he also had some difficulty, I believe, reaching a lot of the freshmen who are taking that course as their science gen ed. And so the school hired me pretty quickly to teach a course 3 times a week at night that basically went over what was just taught in that day's astronomy course in plain language, that people could understand. And that was one of the most rewarding experiences I've ever had. And I've done a lot of tutoring. I've done star parties. I've done more star parties than I could count. And some of those attract, hundreds of people. You go out into the woods and with a whole mess of telescopes and show people around the universe. And, you're trying to explain astronomy and things they're seeing up in the sky to everyone from 4-year-olds to seniors who may have never looked in a telescope before in their lives. And it really is so exciting to me to be able to reach people where they are, to bring science to everyone.
Yes. Spoken like a true science communicator. Yeah. And that I totally understand what you mean with that there. And speaking as someone who doesn't have a traditional background in the field, I myself went to school for history and the social sciences and became an educator in those. But yeah, the having a really big passion for the universe and cosmology and such, I've had to sort of self-educate along the way. And but the funnest part is it's like I want to learn about this so I can teach about this.
Right,
Yeah.
right,
Yep.
absolutely.
Yeah.
And the more you do that, the more you learn yourself. And to
And
me, it's a wonderful education for myself. So that's so fulfilling on that level as well.
yeah. And I think that's probably one of the best things about being a science communicator. And I think it's proof that people really aren't that bad, you know? It's like having knowledge is really good. Good to feel informed and knowledgeable about something, but the best part of that is being able to impart that same sort of thing to others, especially the interest in it.
Hmm.
Oh, but I do
And,
go on.
and you know what I really love? You may find this kind of interesting. I have studied astronomy and sciences every day of my life, pretty for my entire life. Okay. And even if you get my specialty probably is planetary science. You know, I've I've studied a lot about planets and exoplanets for a long time. And every single day I learn what I don't know.
Mm.
I I am overwhelmed by how much more there is to the cosmos, how much more there is to learn. And I am just overwhelmed. I mean, and I'm so fortunate because I get to spend my life hanging out and talking to and interacting with some really brilliant people. And I am just overwhelmed
Mhm.
with with how lucky I am and how much I love doing this.
Oh, yes. It is wonderful to know that, isn't it? There's many things other people can still teach you. And yeah, exciting to see that there's no point in which we can say, yeah, we know everything. And that actually is a perfect segue into my next question because I wanted to know from you, as someone who gets to talk to experts in this field and who has your own background in this field, what would you say are the most pressing mysteries in astronomy and cosmology that are present today? Like, what are the biggest questions that we are hoping to resolve going forward?
I think the biggest question that one of the biggest questions of all is one that we are very likely to answer in the coming years. And that is, are we alone in the universe? Are,
Yes.
are there other life forms? And so, if you ask me, I believe the more I've learned about chemistry and physics, and the more we learn about exoplanets, biology, and genetics, the more I'm coming to the conclusion that life is ubiquitous across the universe. We are going to find life everywhere we look. All right.
Yeah. Yeah.
And that does not mean complex life. It does not mean intelligent life necessarily. You know, for the first half plus life of life on Earth, the only organisms on our planet were cyanobacteria, all right, blue green algae, and those could not build a radio telescope. Obviously, we don't think so.
Mhm.
All right. So we would not have found them, you know, 40, 50 years ago, looking with just SETI, looking with radio telescopes. But now we are developing the technologies, and we now have the beginnings of the technologies to take spectra, to take measurements from the atmosphere of light passing through the atmospheres of distant exoplanets, planets around other worlds, and look for chemical markers of light. So when you look, so when we see light passing through the atmosphere of a distant world, you can now tell its chemical composition. You can tell, is there a lot of methane in the air? Because that's a telltale sign of biological activity, usually here on Earth. And is there way too much oxygen? Those cute little cyanobacteria we talked about earlier were responsible for dumping a whole mess of oxygen into the air, which led to one of the great extinctions in the history of our planet. But at least 40, 50 years ago, we never would have seen a world filled with simple bacteria. Nowadays, we can, because we can detect that there's too much oxygen there, and that, combined with other data, could provide the very first conclusive evidence of life on other worlds. I think that is going to have far-reaching implications, and it's going to something we're very likely to see happen in the next few years.
Yes. Well, I would agree. That's got to be the biggest. And that's one we've been trying to answer quite possibly for the longest, isn't it?
Yeah.
I mean, that's right up there with why are we here? Yes. Which, of course, is a much, much, much harder question to ask. Why? But how did we get here? Yeah, I definitely think we're getting closer to that. And then the next biggest question to that is, well, are there others like us? Do they have thoughts on the matter?
Right.
Let's compare notes.
Right. Speaking of thoughts on the matter and comparing notes, this is kind of cool. Now, think about how large that news is going to be when we discover life on another planet. All right. Now, that is one of the big things that is about to happen to the human race. There are two others. The other one is we are about to reach a point where we have a large number of people in space, living in space permanently. And once there are hundreds or thousands of people living off the face of the planet, that is going to radically change the way that both they perceive life here on Earth, as well as the future of our species. Because for the first time, by moving beyond our planetary cradle, we will be forever protected from worldwide disaster. For the first time in 70 odd years, our species will be safe from the threat of worldwide nuclear disaster, or a massive comet coming and hitting Earth. Extinctions have happened several times throughout the history of our world. And we're going through another one now because of global climate change. All right. But even if all human life on Earth became extinct or irrevocably damaged, there would still exist these colonies on the moon, on the face of Mars, and hopefully beyond, where our species could carry on. And that is another major, major change we're about to go through. And now the third thing that's coming along, okay, this is going to be a perfect storm. The third thing coming along is that AI is about to reach sentience. First time we will have an intelligence that could exceed humans in some ways that will not be human. And someone's going to write to me saying, oh, I'd like to see you swim like a dolphin. I get the idea. All right? Animals have different intelligences. For further information, go back to my talk with Neil deGrasse Tyson about this. We blab forever about this. Okay? But we will have, this will radically change our notions of intelligence and what it means to be intelligent. And those three things together, reaching out into space and living well beyond our planetary cradle, and moving and finding life on other worlds, and AI reaching sentience, of having its own electronic consciousness, to me, are going to form, like I said, a perfect storm of events coming in the next 20, 30 years. And things that we think of as immutable today, nations, currencies, mores, none of them are going to be meaningless in just a few decades. And a whole new mindset is going to be forming. And I think this, what I call the nexus of these three events, I believe is going to be a change in the human race that is greater than any other advance we've made since our distant hominid ancestors came down out of the trees.
Yes. Well, I came to a very similar theory there a little while back about how technological advancement on the one hand, climate change on the other,
Right.
they're going to be pulling us in opposite directions simultaneously. And they're also expected to hit a certain point of inflection or crescendo around mid-century. Yeah. Well, and I very much like the idea that moving parts of humanity off-world is going to have it will ultimately aid in keeping Earth safer, recovering from any calamities. That's what I always tell people whenever they say, "Oh, shouldn't we fix Earth first?" Like the most persistent and annoying question I ever hear. Do you ever get that one?
Absolutely. Matter of fact, I just did an episode a couple of weeks ago explaining that one of the very, very best reasons for space exploration is to save Earth.
Mm-hmm.
We cannot possibly get a good handle on what's happening with the climate, with the atmosphere, with the oceans, just by, sitting on land with windmills and, heading off in boats dropping anchors.
Mm-hmm.
If we hope to mitigate, to study, to learn about, and to mitigate the damages from global climate change, our only hope to do that is to go into space.
Yes. And I mean, that going into space was how we learned about what we were doing to the climate in the first place. We were able to quantify it and study it, monitor it like never before. So, yeah.
Absolutely.
It's very hard to make the case that sitting put is going to resolve our problems here. Yeah. I keep bringing that up, I think I'm trying to preempt anyone from asking it in the future.
Yeah.
Yeah. But
I totally enjoy that question. I think,
Yeah.
I think it's a question that should be asked, and I think there's so many good reasons to go to space. And if you look at it, the amount that we spend on space is pretty ludicrously low in comparison. All right. NASA just got some additional funding, but as of a year ago, they're running around $20 billion a year in funding. That is about equivalent to how much Americans spend every year on potato chips. All right.
Yeah.
And, and there are just so many other things that especially, that the government's spending money on that is probably giving us a heck of a lot less in benefit than NASA and the NSF and such are providing.
Oh, yes. Yeah, to look at some of the programs, to look at some of the things we spend money on, like oil and gas subsidies, for example. Yeah, annually, the world over, we spend, I think, about $5 trillion subsidizing oil and gas companies and cleaning up after them. So,
right.
At a time when we're trying to fight climate change, that is really not money well spent.
Right. Now, here's something interesting. Now, if you think about, let's say, what is the closest comparison to NASA? Well, I mean, in some ways, you have to say, well, closest is maybe the Defense Department, because they're trying to make machines that do things that the machines are really not supposed to do. Okay. And since 1996, the U.S. military has spent $1.5 trillion with a T dollars on the F-35 jet fighter.
Yeah.
And that was they started spending money in 1996 on that thing, okay? And even as late as 2013, the thing could not effectively fly in night or in bad weather. So that $1.5 trillion since 1996 is roughly 16 times as much money as NASA just spent developing Artemis.
And yeah, that is uncanny because that exact same example, I've brought that up there in this same discussion there. It's like all that money spent on a weapon system that up until very recently didn't even work. Do we really want to make this an either or scenario and use space as the sacrificial lamb here? Why not military spending? Yeah.
Right. And, there are a lot of other examples. The amount of money they're looking at is, for NASA, for instance, is roughly 1/2 of 1% of the federal budget. But I think one of the problems is that NASA and scientists in general are almost a victim of being too good. And by that, I mean, if you look at the incredible images coming from the James Webb Space Telescope, or the fact that we're about to put people back on the moon again for the first time in 50 odd years, people could look at that and think, oh my God, that must cost so much money. And if you ask people blindly, I've seen, studies of this, if you ask people blindly, they think NASA or, science represents 20, 30, 50% of the federal budget, when it's orders of magnitude less than that. It's so much less than most people think that it costs. This, to me, is one of the best investments we can make as a society. Just recently did a video the day that Artemis 1 splashed down, with one side of the video shows Artemis 1 lifting off, and the other is just a reel of people talking about how much that launch inspired their kids.
Stay tuned for part 2 of my interview with James Maynard. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.